general physics, and in general physics the topic is moments. And in moments, let's start with some of the questions. This is your question number 1 over here. 3.4 is the topic. Okay, so is it visible to both of you?
Yes, sir.
Okay.
Yes, sir.
Okay, this is a theory question, and this all is based on moments. And I will love to solve this question for you, because the same type of question I discussed during the notes, what I was explaining to you. In this question, it is said that figure 2.1 shows a uniform plank AB of length 2.0 meter. This is very important information. I have to underline this. 2.0 meter, suspended from two ropes X and Y. I told you people that whenever there would be this type of question, that there would be two ropes, then one rope will be basically passing through pivot, or you can consider that one of the rope would behave like a pivot, right? So it would be mentioned, or you have to select by yourself. So the weight W of the plank is 2.1 Newton. I told you that if it is a uniform rod, its weight would be exactly at the center. So here is the center of this rod. So here is center of gravity as well. It is 210 Newton is in this situation. The force on rope X, the force in rope X is P, and force in rope Y is Q. In rope X, force P is there, and in row Y, force Q is there. State in terms of P the moment of force P about B. This is very important phrase. About B means this will behave like a pivot, right? Are you people clear about this situation? This is your pivot now. So when this is pivot, force P about this, yes,
जी सर.
moment क्या होगा इसका? About B, moment of force P. Yeah, you have to figure out as well.
Yeah.
State in terms of P the moment of force P. I mean, moment of this force, the force which is acting at this point in the upward direction. I have to figure out the moment of this force about point P. So when I'm saying about point P, it means I have to consider this distance from,
1.5.
yes, pivot to this point of line of force. So this moment is equals to P times 1.5. You can say it is 1.5 P. Got it? Are you agreed?
Yes, sir.
Yes, yeah. Is it clear, beta?
Yes.
Okay, so if you have any question during this question explanation, please let me know that. Now, calculate the moment of W about B. What is this question? This question is that you have to calculate moment of this weight force about point B. So, what do you say? Which moment will it cause? Clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise, right? Like this. Okay, and that will be 210 times. It would be you can say it is of 2 marks, huh? Oh, sorry, 1 mark. So you can say 210 times. What is the, yes? What is the distance over here?
सर द होल डिस्टेंस पूरा डिस्टेंस होगा या
Nahi,
सिर्फ
just the distance from this point to the pivot. आपका W कहाँ पे लग रहा है? W is over there, and the distance from W to B. So it is midpoint, ना? ठीक है?
यस
So midpoint means from this
1
point to this point. Yeah. What will be distance? Because the total length is 2 meters. Because from this point to this point is 0.5. Okay,
Yes.
from P to Q 1.5. So total length is 2 meter. So this 210 is at midpoint. So this distance is 1 meter. So you can say 210 times 1, which is equals to 210 Newton meter. Is this clear?
यस सर
Yes,
Yes.
yeah. Is it clear, Vita?
Yes.
Sure.
Yeah, sure.
Okay, now you are going to calculate force P. So when we are going to have when we are going to calculate force P, actually we are supposed to equate the moments. So moment of force P, which is clockwise moment, and moment of W, they are equal. That's why this rod is in equilibrium, isn't it?
Yeah.
So I can
Towards
say
the head.
F1 D1 equals F2 D2, and F1 D1 is basically the moment of force P. So you can say 1.5 P, or if you want to rewrite these values, no issue. You can simply write P times 1.5 is equals to F2 is 210 times 1. Are you getting why I'm going to select these values?
Yes, sir.
Yes.
G.
So P will be equals to 210 divided by 1.5. So can you please calculate this for me? Because I don't have approach to my calculator today.
210 divided by 1.5. 140.
1?
40.
140 Newton. Yeah, yeah, are you agreed?
Yes.
Okay, then the last question, the force Q. What will be the value of force Q? How to solve that? Check this one out. The rod is in equilibrium. It means this force is 140. This is unknown because this is passing through pivot, so it will not cause any motion. That your downward force is 210. If object is in equilibrium, can you say that sum of upward forces should be equal to sum of downward forces?
Yes.
Yes. So sum of upward forces equals to sum of downward forces equals to sum of downwards forces. So you can say that upward is P plus Q and downward is 210. So P is 140 plus Q is equals to 210. It means Q is equals to 210 minus 140. So it would give you 70 Newton. Am I right?
Yes, sir.
Yes. So this was that question which was basically your a part of your past paper question from moment. It was October November 2018 question. Okay.
Yes, sir.
Now, uh, yeah, this would be a question. This is a horrible question. I have to explain it from the basic, and then we will move on because this is a blend of different topics. It's not only moment question. May June 2017 variant 2. This question says that figure 2.1 shows a vehicle designed to be used on the moon. This is a vehicle which is used to move on the moon, right? The brakes of the vehicle are tested on the earth, and acceleration of free fall on the moon is 1/6 of the value of that of the earth. So tick one box in each column, the table to indicate the value of quantity when the vehicle is used on moon as compared to the tested on the earth. Right? The question is that the vehicle is tested on earth and then it is there are different parameters which are to be tested over there. One of them is gravitational acceleration. Gravitational acceleration on the moon is 1/6 of that of the earth. Now, what is that mass of the vehicle on the moon? Will it be same, less, or greater? Column one. I'm talking about column one. This one. What
Sir,
about the
mass?
sorry?
Mass?
Yes, mass of the vehicle when it is tested on the moon and earth.
सर मैथ्स हर जगह पे सेम नहीं होती.
Same होती है. Yeah, yeah. Are you agreed?
Yes.
Oh, yeah, yeah. Today you are not feeling well, I think. Is it everything fine?
Yeah, it's fine. It's fine.
Really? Okay. Then let me know what is the weight of the vehicle on the moon.
Weight of that. Wait, wait, this. Same. My weight is 1/6 value of Earth.
Very good. Okay, and deceleration. of the vehicle on the moon with same braking force?
Yes.
Yes,
Same.
same braking force. I mean, this vehicle is applying brakes are applied on it, and it decelerates. So will it take same time? Will it be same 1/10 greater 1/6 whatever?
Mm. It's not affected by gravity, right? So no. Same as Earth.
Yes,
Same as Earth.
same. So Hassan, what's your idea?
Sir, मेरे ख्याल से same as Earth.
Same. Okay, good, good, both of you, because brakes are not affected by gravity. Brakes are affected by the condition of tire and surface between the tire. So they would be same, right? So here you will score 3 marks. So is this question clear to both of you?
Yes, sir.
Now this question is, there is another blend of topics. Here is a piston that shows a braking pedal of the same car, right? And this is basically the hydraulic brake system to somehow. There is let me explain first this diagram, then I will read the question. The force is exerted by the driver over here. Here is the force applied, right? So when the force is applied over here, this is the pivot, and due to this pivot, sorry, the pivot is at the top over here, and due to this, what happens? This piston is moved forward. This piston is pushed forward over here, and when this is pushed forward like this, then what happens? There is a pressure exerted on the oil, and when that oil is delivered to the brakes of the tires, what happens?
It
uh,
slow.
Slows down the car. Basically, it is a braking system, right? It
Yes.
slows down the car.
Car.
So this is what I have tried to draw it for further. Now this question tells us, this is the part where I have to follow the concept of moments. I'm gonna erase this back for the convenience. Now check this one out. It is said that force F is applied by the driver. This force is applied at a distance of 2.4 centimeter from the pivot, and there is a distance of 7 centimeter from the pivot. The force which is exerted on this piston. Here are the liquid particles, and this is one situation. Now let's talk about the question. The driver exerts the braking force on the pedal and increases the pressure of the oil to operate the brakes. The area of the piston of the cylinder is 6.5 exponent minus 4 square meter, which is basically converted to for your convenience. And the pressure is increased to 500,000 Pascal. How much increase in the pressure taking place? 500,000 Pascal. Calculate the force exerted by the driver on the braking pedal. So, actually, our task is this one. We have to calculate this. For this question, to be honest, this is a hard question of your moments. So, remember this thing. If you are going to apply the force, this will try to rotate this setup in this direction. But if there is a pressure on the liquid, and then liquid would definitely be applying the force in opposite direction over here, it would cause the system to be rotated in this direction back. So I can simply say that F1D1, here this is your sorry, this blue one is your, let's say, F1D1, and this red one is your F2D2. Now this D1 D2 is not a big issue. The main problem is your F2. How to calculate this F2? Because this is the force of pressure of oil, force of liquid pressure. So I can simply say, this is a 4 mark question. So first of all, you can say that F1 D1 is equals to F2 D2, because according to principle of moment, I can use this equation. But later on, I let's say I have to calculate F1, and the D1 is the distance at which this force is exerted on. This is the pivot. So from pivot, this force is 24 centimeter away. How much away that force is? 24 centimeters. So I can say it is 24 centimeter, or simply if I convert this, it is 0.24. And F2, I do not know about that till now, but let me figure out the distance at which it is being applied. So what's your idea? Isn't it passing at a distance of 7 centimeter from the pivot?
Yes.
Yes, so here I will use 0.07. Now, F1 is that force what I want to calculate. So it is 0.24. And F2 is the force of basically pressure of the liquid. So I can say F2 is force due to pressure of the liquid. Force due to liquid pressure. So if you have just a small idea, because we did not study this topic, that's why I'm not going to force it for you people, but pressure is equals to force over area, and force is equals to pressure times area. So I can simply say that this F2 is equals to pressure,
500,000 into
yeah,
euro.
times area, exactly. So it is 0.07, because in exam the values are given to us. So pressure is 500,000 times area is 0.00064. Was it 0.00065? Sorry, 65 times 0.07 whole divided by 0.24. This is your F, which is over there. Is this clear to both of you?
Yes, sir.
Yes. Yeah, yeah.
Yes.
Do you want to ask something from this question?
Nah. No.
No? Okay. Yes, calculate, please.
Sir, 94.791666.
94.79.
79.
Right. That's fine. So if this is 94.79, it means we have to round it off to 95 Newton. Right? How much Newton do we have? 95
90.
Newton force is being applied on that. So is this question clear to both of you?
Yes, sir.
Yes. This was one of the.
Sir,
Yes.
ये जो the second pivot F2D2,
Mhm.
how is it going anti-clockwise?
Yes. देखो प्रॉब्लम इज कि दिस इफ आई रिमूव दिस वन ना, ये जो आपका मैंने यहाँ पे लगाया हुआ है, यस, solve this one because size of the eraser is too big. Okay, now if I erase this one, so do you know when this braking piston is pushed forward, this would apply force on the piston, right?
Yes.
Piston over here, and as a result piston would apply a reaction force on this rod, and this rod is basically connected to this shaft over here, right? So impact of this force is passing through this point. Remember this, that's why I told you that this is one of the hard questions. So impact of that force, which is basically being produced to press the liquid, it is passing through this point, isn't it?
Yes.
Right, so this is that force, which is force due to pressure of the liquid. You are going to press the liquid, and
Hmm.
liquid is going to produce you a reaction force. Okay.
Yes.
Okay, clear हो गया?
Sir, the pivot जब आगे जाएगा, it would go clockwise.
हाँ, अब अगर ये आगे जाएगा ना, लेट्स से ये देखो, अगर ये फोर्स आगे इधर को जाएगा तो इट वुड गो क्लॉकवाइज, इज इट?
जी.
गॉट इट? तो ये जो ब्लू वाला है, दिस इज आल्सो गोइंग क्लॉकवाइज, सो बोथ
Yes.
द मोमेंट्स आर इन द सेम डायरेक्शन. So you will not find any reaction force. ये बात समझ आ रही है? So for
जी
principal moment, हमारे पास ये होना चाहिए कि one moment should be clockwise, one moment should be anti-clockwise, or some of the moment should be clockwise and some of the moment should be anti-clockwise. So when you are going to apply the force, this is basically this is uh, anti-clockwise moment, and this anti-clockwise moment is going to counter your force. अब देखो, आपको फोर्स लगानी पड़ रही है किसको प्रेस करने के लिए? टू प्रेस द पिस्टन, ठीक है?
जी
और पिस्टन आपके ऊपर भी फोर्स लगा रहा है, विच इज दिस पर्पल और पिंक कलर फोर्स.
ये
सो
एंटी
मैंने
क्लॉकवाइज
ये
पिस्टन का फोर्स है।
हाँ, ये पिस्टन का फोर्स है.
अच्छा नहीं, मैं वो पिवट का समझ रहा था। मैं इसी को देख रहा था कि पिवट आगे जाएगा, दोनों तरफ से आगे ही
नहीं नहीं
जा
नहीं
रहा
नहीं, पिवट तो नहीं हिल सकता. दिस इज पिवट. पिवट विल रिमेन फिक्स्ड. ठीक है?
है। ठीक है।
ठीक हो गया? इज इट क्लियर?
जी
दिस इज योर
यस
पिवट. सो पिवट वुड रिमेन फिक्स्ड, इट विल नॉट मूव ऑन. सो ये बात क्लियर है? इज इट डन?
Yes.
Yes.
Yeah.
Okay. Now this is another good question. Actually, this is the question which links some couple. That's why I have selected this one. Toe mechanics, and we are trying to use a two-person spanner or a wrench to loosen a nut of a large wheel. Figure 2.1 shows a force exerted by two mechanics. Okay, this is 500 Newton force exerted by mechanic A and 400 Newton force exerted by mechanic B downward. This is the nut which is being opened, right? The total distance from this point of the nut is 1.2 meter on both sides, right?
जी
Okay. Calculate the magnitude and direction of the resultant moment exerted by the mechanics on nut P. This is very interesting question. If you want to open a nut, both of them should create the moment in the same direction. Is it? Yeah, yeah.
सर,
So what are they doing?
they are applying
Mechanic,
force from the
yes,
both directions.
yes. Mechanic A is producing the moment in anti-clockwise, and mechanic B is producing the moment in clockwise. That's why actually they are opposing each other. That's why net moment is difference of both of them. So you can say net moment is equals to f1 d1 negative or minus f2 d2, because they are not in the same direction. If they would be in the same direction, you can add them. Is this first step clear to both of you?
यस सर।
Okay, so f1 is 500 newton, I mean for force of mechanic A, and it is applied at 1.2 newton, and f2 is 400 newton, and it is also at 1.2 newton. So what will be the resultant answer?
600 minus
400, 4,800. Sorry, 48,
48
480,
120।
right? So it is 120 Newton meter. So resultant moment is 120 Newton meter. So if I ask you the direction of the result, oh yes, it is asked. So what is the direction of the resultant moment? Yeah, yeah, Hassan,
एंटी क्लॉकवाइज।
anti-clockwise, right? Yeah, yeah. Is it not clear to you?
No, it's clear.
Clear? Okay. So that is anti-clockwise rotation. I mean, this moment is bigger, so this moment is having more impact. Now, the mechanic B reverses the direction of 400 Newton force that is exerted on the spanner. So mechanic B was applying some force basically in a wrong direction. So he has reversed the direction of this force. Now the force is 400 Newton in this direction. Are you getting it? It means now this mechanic is causing the moment to support mechanic A's movement, right? So this
Yes.
nut will basically untie in this way. It would cause the rotation like this. Okay, now the mechanic A continues to exert the force of 500 Newton downward. Calculate the magnitude of the new resultant moment exerted by the mechanics. Yes. So what will you do? This will
Add
be F1 D1 plus F2 D2. This is a new resultant moment. So F1 is same, 400 times 1.2 plus F2 is 500. Sorry. Reverses the direction of 400 Newton. This mechanic A was applying 500 Newton. 500 Newton times 1.2 plus 400 newtons times 1.2. So what would be the total answer now? 1.6, sorry, 600
plus
plus
480 equals
480. So
8.
1080. So 1080 Newton. You can round it off to 1100 Newton meter. This can be done, but 1080 is the logical answer. Calculate the magnitude of resultant force now exerted by the mechanics on the spanner. So how much force do they exert on the rod or on the spanner? So one is applying 400 Newton upward, the second one is applying 500 Newton downwards. So what is the resultant force?
Minus 100.
Yes. So 500 minus 400. So it is almost 100 Newton. So if you use negative sign, it means upward or downward, but it's fine, no issue at all. Okay.
Yes, sir.
Okay. Now this is the question. I would discuss this question as a last theory question. Then maybe we will. I will give you some assignment. This is question number 4. This is October number 15. Question number 4 of variant 2. Okay, this question shows that in figure 4.2 shows two elephants pushing horizontally against a vehicle of with a force of 11 kilonewton at a distance of 1.8 meter above the ground. Point M is the center of mass of the vehicle. This is somehow a question from National Geographic. A car is there, and then it is being not a car, actually a truck or a vehicle is there, and this is being pushed by the elephants, the one elephant, and the elephant is applying a force of 11,000 Newton at a height 1.8 meter above the tire, about point A. This is basically very important point. This point, and the I mean to say that the weight of the vehicle is actually weight of the vehicle is how much is acting over here. It will be given to you to somehow. Probably it will be given to you, right? Because if mass is given, then definitely we can find the weight. Now let's talk about not yet, not yet. Okay,
आगे दिया
calculate the moment about A. Calculate moment about A of the force exerted by the elephant. So how to solve that? Moment about A means from this point to this point. At what distance this elephant is applying the force?
1.8.
1.8 Newton. And how much force it is being applying? 11,000.
11.
It means it is producing anti-clockwise moment. So you can simply say that it is F times D, which is basically equals to 11,000 times 1.8. So what will be answer?
11,000 into 1.8.
Yes,
The answer is 19,800.
19,800 Newton, which is almost 20,000 Newton. Got it?
Yes, sir.
Okay. Now, uh, exactly. The mass of the vehicle is 1900 kg. What is mass of the vehicle? 1900 kg, and does not slide when pushed by the elephant. It does not slide. It means either it would topple over or it would rotate. and determine whether the elephant will topple it over or tip it over or not. Show your working. So what's what's the condition of toppling over? If the moment of the weight is in this direction, so what is the mass of that? 1900 kg into 9.81 is basically the weight of that car, because that is mass into weight. Weight is equals to m times g. That's why I have selected this one. So this is causing a moment clockwise, right? This moment is clockwise and this moment is anti clockwise. So if I say that both of the moments would, if both of the moments would be greater, it would have no impact. If the moment of elephant would be greater, it would be tipped over. If weight of the if moment of weight will be greater, it will not tip over, right? So I would calculate both of them. That F1 D1 is, I mean, you can write in this way: moment of elephant is, we have calculated that or not?
No.
Moment of elephant. Sure?
यस सर, एलिफेंट का तो कुछ दिया हुआ ही नहीं है.
Yes. No, no, no. ये 1. देखो, this was the force, 11,000 Newton force was applied by elephant. So this is the moment of elephant.
अच्छा, हाँ, ठीक है, ठीक है.
Moment of elephant था ये.
ठीक
Okay,
है.
yeah, are you getting it too?
या क्लास में नहीं है सर मेरे ख्याल से.
Oh, अच्छा, किधर गया वो?
अभी अभी निकला है.
Okay. Yeah is back. Yes, yeah.
Yeah, it was connection problem. Sorry.
Oh, no problem. So we were saying that when you were in the class, we have calculated moment of elephant. So what was moment of elephant? Moment of elephant was this one, R 19,800 Newton, right? So it was 19,800 Newton meter, and we can calculate moment of weight of the car. Moment of weight can be equal to m into g into, what distance should I write for the weight of the moment from here?
2.5.
2.5. Sure.
ये 1.25 का डबल नहीं होगा?
This is pivot. Okay. So the distance from pivot to this weight is 1.25 meter. Right. So you will
Yes.
write this distance. Actually, this is your F1 and this is your D1. Okay. And then this is your F2 and this one is your D2. So D2
Yes.
is 1.25. So you will write mg into 1.25, which is equals to, mass is 1900 kg into 9.81 into 1.25. So please calculate this one.
9.81 से मल्टीप्लाई करूं?
जी.
23,298.75.
23,000.
298.75.
Yeah, it can be rounded up as 23300 Newton meter. Right? So
Yes.
isn't it greater than the moment of elephant?
Yes. So it
Yes.
would not
So it
be.
would not tip over, as moment of weight is greater than moment of elephant. So it will not tip over. It will not
Tip
tip
over.
over. So is this question clear to both of you?
Yes, sir.
This was a good question to be asked in exam, right?
सर ये आप कर रहे हैं, समझ आ रही है. जब हम पता नहीं करते हैं फिर कुछ नहीं हो रहा होता.
Actually, आपने ये करना है कि you have to figure out the key concept in all these questions is figure out the distance and force F and D. If you are able to calculate F and D, everything would be in your hand, right? For example, yes, let's have a short calculation on this one, right? I will not solve all of the question, but the part which is basically containing moment. Yes. So here, this is your arm. This is the practical question. Practical question. In this question works in our daily life in our hand. This is the pivot, right? It is mentioned as P. This the center of the arm is having a mass of 20 Newton, and a 120 Newton load is lifted by your hands, and this is the force exerted by your muscles. Okay, this is a force exerted by your muscles in the upward direction. अब आप देखो, this is the distance for this force. This is F1, this is your D1, this is your F2, and from this pivot to this point, this is your D2, this is your F3, and you can say this is your F3, and distance from this pivot to this line, it is your D3. Am I right?
Yes, sir.
So you can say F1 D1, because this is causing counterclockwise movement. These two are causing clockwise movement. So you can simply say F1 D1 is equals to F2 D2
P2 plus
plus
F3
F3
T3.
D3. So just plug in the values. F1 is not known to you. What is D1? D1 is 2 centimeter. So you can write 0.02, because it is not in centimeters. Sorry, it is now converted into meters. And then what is this?
20 into 15.
Yeah, 20 into
0.
0.15 plus what is F3? 120 into 0.33. So when you are going to calculate this all, it would be 20 times 0.15 plus 120 times 0.33 whole divided by 0.02. This would give you the answer. Got it?
Yes, sir.
So I did not get in formalities for this question. I just did it that what is the force required by your muscles. So what is the answer?
Uh, 2130.
Which is rounded as 2100 Newton. Got it?
Yes, sir.
Yes. Yeah. Beta, is it clear to you?
Yes, yes. Clear.
Yes. So I will send you this worksheet. Please, a request to both of you
Okay.
that solve it, because Hassan has taken the MH photocopier. These questions would be there definitely. And for you, I'm going to send it, and please take out prints and solve it. Okay.
Okay.
In
Yes,
next
sir.
class, we will discuss this all. Got it?
Yes, sir.
Okay then. See you inshallah. और कोई चीज पूछने वाली तो नहीं है?
नहीं, sir.
Okay then.
Allah Hafiz.
Allah Hafiz.